There are moments in science when everything shifts. Not gradually, but all at once. When a discovery doesn't just add knowledge, it challenges reality itself. This may be one of those moments. When the James Webb Space Telescope was launched, it carried enormous expectations. We believed we understood the story of the universe. Webb would simply refine it. Show us the first galaxies. The birth of stars. Maybe a few surprises along the way. But nothing that would fundamentally break the rules. We were wrong. Because behind the stunning images, the glowing nebulae and distant galaxies, there is another layer of data. Raw. Unfiltered. Chaotic. Photon arrival times. Thermal fluctuations. Background radiation noise. For years, much of this data was considered too complex, too messy to interpret clearly. Until recently. A research team working with Google Quantum AI applied advanced machine learning systems to analyze these deeper datasets. Not looking for images. Not even looking for known physics. But for patterns hidden inside noise. And that's where things became unexpected. The system began identifying correlations across distant regions of space, areas that should have had no connection at all. Light behaving in ways that didn't fully match predictions. Subtle irregularities in how gravity bends light, what scientists call gravitational lensing. At first, these were treated as anomalies. Measurement noise. Instrument limitations. But they kept repeating. Some of these patterns appeared almost symmetrical, mirrored across space in ways that raised new questions. Not evidence of something artificial. But hints that our models of the universe might still be incomplete. That what we call empty space may be more structured than we realize. Then came something even more intriguing. When researchers analyzed background radiation signals at extremely fine scales, they noticed recurring numerical patterns. Not messages. Not codes. But statistical structures that didn't behave entirely randomly. Now, it's important to be clear, the human brain is extremely good at finding patterns, even where none exist. So scientists approach this kind of result with caution. Very cautious. Still, these findings open up deeper questions. Is the universe truly random at its smallest scales? Or does it contain hidden order we don't yet understand? Another area of interest came from unusual alignments in deep field observations, regions where galaxies appeared more coordinated than expected over vast distances. Again, not impossible. But not fully explained either. These observations don't break physics. But they push against its edges. And that's where the real story begins. Because none of this proves the existence of messages, mirrors, or external intelligence. What it does reveal is something more important: we are still early in understanding the universe. Much earlier than we thought. Even concepts like time and causality, once considered stable, are now being explored in more complex ways. In extreme environments, like near black holes or in early cosmic conditions, time doesn't behave the way we experience it. It stretches. It warps. It overlaps. So when unusual timing patterns appear in deep space data, they don't necessarily point to something supernatural, but they do remind us how strange reality already is. And then there's the role of AI itself. Modern systems don't understand in a human sense. But they can detect structures across massive datasets far beyond human capability. Sometimes they reveal patterns we didn't even know to look for. Other times, they highlight noise in ways that feel meaningful, but aren't. Distinguishing between those two is one of the biggest challenges in science today. So where does that leave us? Not at the edge of a cosmic revelation, but at the edge of deeper curiosity. The universe may not be sending us messages, but it is far from simple, far from empty, and far from fully understood. What the James Webb Space Telescope has truly done is this: it has removed our illusion of certainty. It has shown us that beneath the beauty of galaxies and stars lies a deeper layer of complexity, one that challenges our assumptions and invites better questions. Because the real turning point in science isn't when we find answers. It's when we realize how much we don't know. And maybe that's the most powerful idea of all. Not that the universe is speaking to us, but that we are finally learning how to listen.